Let's talk a little more about evaluating inverse trig functions. So in this example, I'm going to evaluate sine of arc sine of negative 0.1. Now, first of all, everything in the brackets here, that arc sine of negative 0.1, let me write that here. So arc sine of negative 0.1. That's the same thing. The arc sine is the same thing as inverse sine of negative 0.1. Okay, those are the same thing. In both cases, they represent an angle. So arc sine of something, whatever it's equal to, it's some angle. Call it theta. And same thing, right? This is that, so this is also equal to some angle. Now what we often do is we like to undo, if you will, inverse notation. So saying that inverse sine, or arc sine, saying inverse sine of negative 0.1 is theta, that logically is the same thing as saying sine of theta is negative 0.1. So we can write that sine of theta is negative 0.1. Okay, that's all these statements are telling you, that sine of that angle is negative 0.1. Now it turns out that there's another condition imposed upon the angle. When you have inverse sine, the output, that is the angle you're talking about, always lies between pi over 2 and negative pi over 2. So not only is this true, but theta must lie between, it's got to be less than or equal to pi over 2, but greater than or equal to negative pi over 2. Okay, so these are the two properties on the angle theta. So back to our original problem, that I was just dealing with what's in the brackets there, right? Arc sine of this. So all of that, arc sine of negative 0.1, it's equal to the angle. Let me just replace it with theta. So let's just write this as sine of all of that stuff, right? It's just theta. So we have sine of theta. Now why would I do that? Because I'm trying to draw attention that we're simply taking sine of that angle. And what is our angle? What are the two properties of our angle? Well, the first property is that when you take sine of it, you get negative 0.1. Oh, wait a minute. Isn't that what I'm doing here? Am I not taking sine of the angle? I am, and so according to this, what I get is simply negative 0.1. Okay, and that would be my answer. Notice that this never came into play. This was just to make sure that we knew what the value, where the angle was. It was between negative pi over 2 and pi over 2, but we never explicitly used that. Notice that in this case, our answer, the negative 0.1, happens to be the number that occurred here. And so that is the reason why we think of sine and arc sine as inverses, because under certain conditions you'll simply get back the angle, or the value rather, that you started with. Okay? Let's try another one like that. Let's take cosecant, that's CSC, of arc cosine of 4/5. And as soon as I see that arc cosine of something, I say, oh, wait a minute. Arc cosine of this, that's going to give me an angle. So let me write that over here. When I see arc cosine of 4/5, I immediately think to myself, oh, that's going to be an angle. Call it theta. What angle? Well, it's going to be the angle such that when you take cosine of it, you get 4/5. So cosine of the angle I'm looking for is going to give me 4/5. Now, the extra condition, of course, on that angle is that the angle's got to lie between pi and 0, or between 0 and pi. So let's go back to our original problem and replace arc cosine of 4/5 with the angle, call it theta. And I want to take cosecant of that angle. Now to take cosecant of an angle, what do you need? Well, you need the r and you need the y corresponding to the angle, right? So an angle always gives rise to x, y, and r, and cosecant involves the r and the y. Now cosine of the angle is 4/5, but cosine doesn't involve the y. Cosine of an angle is simply x over r. So let's call the 4, call that x, and the 5, call that r. So my x is 4, and my r is 5. And knowing the x and the r, can you find the y? You can, right? Because we know that x squared plus y squared equals r squared, always. So that y squared is r squared minus x squared. So y squared is equal to, well, r squared is 25, take away x squared, which is 16. So y squared is equal to 9. Now that means y is equal to either positive or negative 3, right? The square root of 9. Now you have to decide, do you want the positive or the negative? And the answer is going to be based upon our angle, right? Our angle is between 0 and pi, so that I know that any angle between 0 and pi is going to have a y-coordinate of positive 3. So our y is going to be positive 3. And that means cosecant of that angle, right? Cosecant of that angle is r over y. So it's 5 divided by 3. So this would be our answer, 5/3. Now there's another way of viewing this problem that people often do. They draw an associated right triangle. So what we can do is say that, well, what do we know? Let's draw our triangle here. So this is a 90-degree right triangle. And what we know is that cosine of our triangle, or sorry, cosine of our angle theta is 4/5. Now that means the x is 4, so if this is our x, that would be 4, and then the hypotenuse would be 5. And the question is, what would this be? And our answer is, well, 3. So you basically complete this right triangle, and you end up getting, well, cosecant of that angle must be 5 divided by 3, okay, which we found. Now it's the same thing as saying the y is equal to 3, right? You're just doing it visually when you draw that triangle. Now there's one point that you have to be a little bit careful with when you do this, and it's that sometimes we're going to have values that are negative. And it's a little bit of a strange thing to draw negative values, because usually these values imply lengths. But when we do so, it's with the understanding that it's really a coordinate we're talking about, and we're representing the triangle as a visual representation of those coordinates. Let me show you what I'm talking about now with another example. Let's say you want to find sine of inverse tangent of negative 2/3. Okay, so once again, let's start with the inverse function. So we have inverse tangent of negative 2/3. Call that equal to theta, right? Because the output of an inverse function is an angle. So that means, that implies that tangent of the angle is negative 2/3. Now this is inverse tangent we're talking about, so the angle's got to lie between pi over 2 and negative pi over 2. So what we have here is an angle such that tangent of the angle is negative, and the angle's in either the first or the fourth quadrant. Let's go ahead and draw this in now. Let me just go out and draw a set of axes here. So this is x and this is y. So the question is where's our angle? Well, it's either 0 to negative pi over 2 in here, or 0 to positive pi over 2. And because tangent is negative, that means we must be down here. So let's draw that in. So we're talking about an angle. So we've got like this. Okay, so this will be our angle theta. Now, tangent we know is y over x, right? So let's write that as y over x. Now, should x be, so one of them's got to be negative, right? Because we get a negative. Is y negative or is x negative? And looking at this triangle, well, where the angle is located, I can see that the y-coordinate is negative, but the x-coordinate is positive. So if you draw in this triangle, which is fine to do, if you draw in this right triangle and you want to label things, well, you have to remember the y is negative, so you'd write y is negative 2, right? I put the negative with that 2 right there, and the x would be positive 3. So remember, these don't necessarily represent lengths anymore. They're simply telling you the values of the coordinates associated with this point right here. And the question now, of course, is what is r? And r is always, r squared is always x squared plus y squared as usual. So r squared is equal to, well, x squared is 9 plus y squared is 4. So r squared is 13, which makes r the square root of 13. And r is always positive, right? Because it's the radius of the corresponding circle. So going back over here, let's say, what are we doing? We're taking sine, again, of that angle. But sine of an angle is y divided by r. And the y, of course, is negative 2. So the y is negative 2, and the r is square root of 13. And then you can wrap, this would be your answer, this is fine, or you can rationalize it and multiply top and bottom by root 13. So it's negative 2 root 13 over 13. Okay, so these are ways we evaluate inverse trig functions, but when people talk about drawing a triangle, remember that the sides can be negative. That's kind of a strange thing, but that's because you're really just representing the values of the sides encode not only the lengths of the sides, but also the signs associated with the corresponding coordinates. Okay, until next time.